We're going to finish up our discussion of files, and then we're going to look at Python exceptions, because exceptions and catching them kind of goes with files. At least it's a good way to introduce the topic. Now, building on what we talked about last time with being able to open a file, the book goes into some detail about storing records in a file and then being able to retrieve those records. Now, there's more than one way to do it, but a simple way that the book introduces is something like this. So we going back with our movies theme here. Let's open a text file called movies, and let's see, this back to where it needs to be, and let's specify that it's reading and not writing or anything else. And just for clarity here, remember you can right click here. I right clicked and choose show and explore and navigate to wherever your folder is. In my case, it's right here. And this is what we're going to be reading in. It's a movie name, a movie year, the amount it made in millions, and the rating. And then the pattern repeats. The pattern repeats a third time. So with that in mind, we can read in. We're going to get the first line of the movie, of the movie list, which we just saw, and the first line is was The Matrix, I believe, right? Yeah. Okay, so the first line is the name of the movie, and that's why we call it names. That makes sense. We're going to read that line. Helps if we spell it right, though, right? And then let's see, while we're not at the end of the file, that's what we're saying here, just like in the last video. And now we can set up our process here to get all of this information back out. So I'm just going to take and copy and paste that, and see, what do we say? It was year, then revenue, and then the rating, right? All right, that all looks good. And then let's see, we're going to say name equals year dot, and remember rstrip, it takes off these invisible new line characters, these carriage returns that cause a text editor to go to the next line. That's how the text editor knows to go to the next line, is that there is a hidden character on the back end of this text. So we're saying we don't want that hidden character, that new line character in our data, because then when you print it, it adds a line, and it's a big hassle. So this gets rid of that. rstrip gets rid of any of those new line characters. And then I think we can just probably copy and paste this a few times. And again, this is a simplistic way of doing this. There's other ways, more sophisticated, but here in an introductory course, we won't get anything too complicated. And we probably should put in, see what, name, it's name, year, revenue, and rating. That's the order, because this just pulls it in the order that it is. Make sure that's right. Name, year, rating, and revenue and rating. Yeah, good. So the first one, the name, each time is obtained right here, while name is not equal to pounds to an empty string. Now it's doing the comparison, but it's getting the next name of the movie each time in order to do that comparison. So that's why we have name here, where we're stripping each one of these, but we're not stripping it, we're not reading it up here, because we've already read it here. That may be a little confusing, and I can see where it would be. I can, that's why I'm trying to explain it here. But let's see, let's go one step further here, and let's print name, and then, so this would be the name of the movie. And then I think we can copy and paste this a few times and put in year, year, revenue, and rating. Also change this to year, revenue, and rating. Then we'll print a blank line here. And then we need to get the next line as well. So we're going to walk through this so that it makes sense. And before I forget, let me close file. When you get done with the file, you should always close it. So let's take a look through this. So we open the file and we get the name of the first movie. And if there's not a name of the first movie, then this whole block of code never executes. And the file is just closed and that's it. Of course, we know it has data in it. So we know it's going to run. And then the next thing it gets is it gets the year, the revenue, and the rating, strips off those new line characters, and then it prints it. And then it prints a blank line. And then we have to get and see if there's another movie in the list, because the code doesn't know how many. The code has no idea what we have in this file. It's just told, all we did is tell it to open a file. Top. Name we have to get the next name if there is one, because remember the while comparison looks for that. And when we get down here at the end of the first run gets just that data right there. At the end of the first run, it's going to pick up Gladiator next. And Gladiator's not an empty string, so it's going to execute again. It's going to populate year with 2,000, revenue with 460, and rating with 8.5, strip it all off, and then print it. And then it's going to try to get the next movie, which will be Secondhand Lions. And is Secondhand Lions an empty string? Well, no, it's not. So we're going to do all this again, get all that data, and then it's going to, after that, it prints it, and it prints an empty line. And then after all that, it again tries to get the name of the next movie, but there's not one. So it does, in fact. Name is now an empty string. So it doesn't execute again because it says while not an empty string. Well, name is an empty string. So this never executes again. And then the movies file is simply closed. That's the way it's supposed to work. Let's see. Let's give it a test here and see if we broke anything. And we had a lot of stuff flash up. Let's scroll up and see. That looks right. The revenue in millions, the rating of each of these movies. And so that's how you read one way of reading records from a file. In this case, the assumption we're making is that each record takes 4 lines. And obviously, if we disrupt the syntax of this file, if we add something new here, a new line, our program cannot deal with that. It breaks. So it must be 4, each record must be 4 lines and only 4 lines. That's one drawback of this method, but it's an interesting basic method that the book introduces, and I thought it was worth pointing out here and walking you through it. Now let me just comment all of this out. I think we're done with it. Let's move on into exceptions. Even though we try to write good code, life happens. And bad things happen. Unexpected things happen. And there are certain events in programming that are considered to be exceptional events. They are events that are likely to cause an error. For example, if I tell you, let's get some input from the keyboard, and I say, hey, give me an integer. Enter an integer. And I really want an integer. I don't want anything else. That's why I'm asking for an integer, right? So we do that. And then if we say something like, right, we're going to print what was entered and multiply it times 10. Let's run this. So I put in 5. It's multiplied. Whoops, that's unexpected because I forgot to make this an integer because it comes in as a string. So let's try that one more time. Integer 5 and 50. That's what I was expecting. So we convert the string to an integer, and then that's multiplied times 10. So 10 times 5 is 50. But what happens when we get something that's unexpected? The user enters the wrong data, for example. Well, the program crashes because we assured the compiler, or the interpreter as Python uses, that we're getting an integer, and that's just not true. We didn't get an integer. And so the Python interpreter throws up its hands and says, I don't know what you want me to do here. You told me an integer was coming, but it wasn't. So what can we do about this? How can we handle exceptional situations, or situations ripe for an error or ripe for a problem? Well, what we can do is we can say try. There's a Python construct called try. And now we're going to say, we're going to do this conversion here, where data equals data, which is a string, right? It comes from the keyboard in a string. And now we're going to convert it to an integer. We're going to try to, just like it says. We're going to try to do that. And if it doesn't, then we're going to say this was not an integer. And I believe we can just go ahead and pull that off. And maybe then this simple example, we'll just exit the whole program. So let's read through this. We get input from the user. We store it in data. We try to convert that data. Hopefully it's an integer. And we're going to explicitly convert it into an integer. We're going to try to. So literally, we try to do it. If it fails, if there is an exception, this executes. If it's not an exception, this skips. There's no error. This is skipped. So if the program was going to crash, this is executed. If the program is not going to crash because of this, then this is skipped. And the data down here is printed. So let's try this. Integer, let's enter a 5. And it prints 50, just as we expected. It tried to do it, and then this was skipped because there was no error. There was no problem. But let's try this. Let's try A. Rather than crashing like it did a few moments ago, displaying all that ugly red text, now it says, hey, okay, this was our problem, and it reports it back, which is pretty interesting because here you could call a function if you wanted to. If you don't have to exit the program. I'm just doing it here for it's just because this is a simple demonstration program. But you could exit it. You could enter a function here and transfer control to some other part of the program, or you could simply if this were part of a while loop, you could do continue, and again ask the user to input the data. And if they fail to do it right, again, you send it back up again. So that's the general idea of an exception in Python. We surround the risky part, the risky command that we might have, with try. We indent, and then the same thing with except. Let's move on. That's a very simple example. Maybe another more interesting one might be, let's see, div. Let's do some division. Because as you may know, it is not possible to divide by 0. And a lot of people are thinking, well, I tried to forget all those math concepts back in high school and grade school. But remember a dividend and a divisor. You can do division. Can't divide by 0. So if we do, we'll get an error. So let's see. Our quotient, we're going to divide the dividend by the divisor. We're going to put that in try because there's a couple things that could go wrong here, right? And this time we're going to try a different type of an exception. We're going to show you a value error exception. Before, we just had this type of an exception. This catches everything. Doesn't matter what type of exception it is. It doesn't matter what caused the exception. Except catches everything. More specific exceptions like this only catch certain types of things, like this right here. Divisor or dividend was not an integer. That's a value error. And let's try another one. Let's see. Except zero division error. This is division by zero. A computer can't do division by zero because the answer is not a real number. And let's just throw in an exit on these. Again, you could do your own thing here. You can make a function call. You could just continue on after you've taken the error. The bottom line is this exception keeps the program from crashing, and what you do after that is up to you. So now if we, let's see, I guess we should print the quotient too, right? The product, or not the product, but the answer from the division called a quotient. Let's give this a shot. Let's see, let's run this. And take 10 by 5, and the answer is 2. Okay, that seems good so far. Now let's run this and put 10 divided by 0. And it says, hey, the divisor cannot be 0. Okay, that keeps the program from crashing. The program would have crashed right here. And let's try another one. Let's see, 10 divided by a, which is not a number. And it said, if you've got to enter an integer. And you know the program will crash because I showed you that a few moments ago. So this is a way of stacking one exception on top of another. The book goes over several different types of exceptions, and there are even more than what the book presents. And let me see, let me go ahead and comment these out. And let's look at the same deal now that you have a little experience with try and except. Let's look at I believe it's the file that we looked at earlier. Just going to paste this in here. And we're going to correct these indentions. This is a file that we looked at, or some code that we looked at, I believe, last video. Let me do a reality check on, I'm right-clicking there and I'm choosing directory path. Oops, I didn't mean to do that. I want to show and explore. I can see the directories, and let's see input here. This is our input file. It's still there. That's good. So we're going to open up this file and we're going to read the lines. And while the first line is not empty, it will get each amount and print it. We looked at this last video. And then it gets the next line before it exits the while loop, so it knows ahead of time, so it can compare whether to enter the loop again. So the issue here is, how do we combine exceptions with this? So what we need to do is we can put a lot of this in a try block. Because we could have some errors here, right? If this file doesn't exist, is that going to produce an error? Yeah, in fact, the program will crash. So that should be in a try block. And down here we could have an issue with, we're assuming that what we get from the file is an integer. We're promising the interpreter it is. We're casting it. We're casting the string to an integer. If it's not, what's going to happen? Well, the program's going to crash. And let me hit enter here. It's complaining at this point because we don't have an exception block as well, the except block. I was making sure there wasn't anything else wrong with the code. So yeah, let's see here. We could do an IO error. The book talks about that. That makes sense. An IO error refers to input output. So some sort of disk problem, like most commonly, the most common error is that the file is missing. Or it could also be that you have hard drive failure or some other type of weird error, unusual error. Let's see, another exception would be a value error. That's going to refer to us casting that integer up there. If we cast the string to an integer and it's not really an integer, it's going to crash the program like we saw earlier. This will stop that issue. And then the original exception that we looked at, right? This is a catch-all. We go from more specific to less specific. And then, of course, we're going to close the file at the end. Actually, yeah. So, actually, I may just go ahead and pop that off here for now. And so this is a catch-all. If this error doesn't trigger, this error doesn't trigger, but there was some other kind of error that we haven't anticipated, then this catches it. We could just delete these and have this alone. There's nothing wrong with that from a syntax perspective, but it's generally helpful to trap errors one at a time, and then that way you can give customized messages. You can also do different things. Maybe you want to do something different for this error than you do for this error. That's good to know. And I'm going to delete these spaces here. So if we run this, let's go ahead and give this a shot here. We can see that it printed all the numbers. So let's experiment around a little bit. Let's come back over here and let's change the file name to inputs.txt. So it's misspelled relative to what the program's looking for. It's looking for this. But now it's not going to be able to find it because I know I just renamed it, right? We know that's going to fail. And it tells us an error occurred trying to read the file. So that means it hit this right here, that error. If we go back here, change this back. And now let's do something, get rid of the movies for a moment. And let's put an A right here. Remember, we promised it would be an integer. A is not an integer. And let's run it with that. And you see it actually processed what it could until it got to the point, using the while loop, it got to the point in the file where it hit that A right there. And then it said, hey, I can't, this right here is where the error occurred too. I can't cast A to an integer, and that's when the value error hit. Now there is one more interesting thing I want to show you here. We can convert each of these like this. And then down here we can simply print this. What we're saying is we want the original error. May not let me do it there, but this is enough to give you a flavor. So let's run this again. And this is reporting the original, this is our custom error here, right? Non-numeric. And then right here is showing you the literal error or the verbatim error from the Python interpreter. Sometimes that's very helpful.